What's up, AP Stats? Today's video is super important because a lot of secrets will be revealed today. So let's go ahead and jump into this and start with notes. This is day 2 of our significance test about differences in proportions. As you might notice right here, I'm teaching you the calculator shortcut today. And I'm doing this for significance tests and also confidence intervals, so get excited. So here's a shortcut. You're going to go to Stat in your calculator, then you're going to go to Test, and then number 6 is the 2 proportion Z test. So that is the shortcut for significance tests. Sig test. All right, let me give you the notes for the shortcut for confidence intervals. So confidence intervals were what we did in the previous chapter, but they're going to come back because they are related to significance tests. Stat, test, same place, except for you're going to scroll all the way down, I'll show you guys this later, to B. Basically your calculator runs out of numbers, so they start using letters of the alphabet. And then it is called 2 prop Z int for interval. So notice these two are like very similar in name. One is for the significance test and the other one is for confidence interval. Confidence intervals. Okay, so this is what I need you to write down in your so you know in the 4-step process, state, plan, do, conclude, this is what you need to write down for the do section. So when you're doing a significance test, in the do box, the only thing I need is the Z, the test statistic, and the p-value. I don't want to see any other work. Of course, you can put work, but my teacher has always told me when I was a student, like, don't show your work for how you found the test statistic, don't show your work, the normal curve for p-values, because if you make a mistake, they will deduct points. However, if you have the correct Z, like this thing, the test statistic, and the correct p-value with no work, you get full credit. Sounds backwards? Yeah, it does. Okay, for the confidence intervals, this is what you need to write down. For the do part. Just write the interval in this format, the parentheses, with your smaller number right here and then your higher number right here. Okay? Literally, that's it. This is mind-blowing. It saves so much time. Okay, so let's jump right into this example problem. I'm going to, I'm just going to go ahead and do the 4-step process. State, plan, do, conclude. So here we go. Student government at a really big high school is wondering if juniors or seniors are more likely to attend prom. Okay, blah, 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 blah. I like kind of just zoom into this last line right here. Does the data, I made a typo right there. Should be does. Oops. Does the data provide convincing evidence that a higher proportion of seniors are going to prom than juniors? So here, I'm going to highlight it. That's what they want us to test. This is actually the context for the alternative hypothesis. It's usually tucked into like the very last line. So we want to see if more seniors are going to prom than juniors. All right, here we go. Oh, I forgot to annotate. Sorry. So let's do juniors first. So there's 50 juniors, 28 are planning to go to prom. So for the juniors, the p-hat's going to be 28 out of 50. And then for the seniors, 45 seniors, 29. So the p-hat for the seniors, p-hat, I'll put senior right there, is going to be 29 out of 45. This is juniors. Okay, so let's start with state. I'm going to make this box my state. So I need the name of the test. Well, anytime there's they're asking for convincing evidence, it's going to be a significance test. And there's two proportions. How do I know that? Well, we're talking about seniors and we're talking about juniors. So the name of the test is two proportion Z test. Okay, the next thing I need, my two hypotheses. Okay, the null hypothesis is always going to have an equal sign. And we're dealing with two proportions here, so I am going to name them P1 and P2. Normally, I like to do like PS and PJ for seniors and juniors, but I'm just going to do P1 and P2 today because I'm being really boring. All right, and it says seniors, more seniors than juniors. So let's make P1 the seniors, and if it's more than juniors, then P2 should be less than. So I have this. Great. Let's define the variables I use. I use two variables. I use P1 and then I use P2. So I need to know what those are. P1, I said that was going to be seniors. So true proportion of seniors going to prom. Okay, that means P2 is going to be juniors. I'm cheating here. Sorry, guys, if you don't have copy and paste. So P2 is going to be a true proportion of juniors. So last year, my students asked me, does it matter if I do P1 for the seniors or for the juniors? Like, does it matter? No, it doesn't matter. I could have made P1 be for juniors, as long as you make P2 for seniors. It doesn't matter how you choose to assign the values. So that's it. I have the name of the test, my two hypotheses, and defined my parameter. So let's go ahead and go into plan. The only new thing about plan today is the large counts condition. So just watch, I guess. So first condition, random. We're using a random sample. So it says random sample here of juniors, random sample here of seniors. Okay, so I'm just going to go ahead and quote that. Random. Safest thing to do is to quote. And then, kind of lazy here. Let's just copy and paste this. How many seniors? 45. Okay, so we have random condition taken care of. Let's do the 10% rule. There's two groups, juniors and seniors, so you're going to have to do the 10% rule twice. This is what I mean. So there were 50 juniors right here, and what's 10 times 50? Well, you just add a 0, and that's going to be 500. So I'm going to say assume more than 500 juniors at this school. I'm going to say that's a pretty safe assumption to make. You want to know why? Well, they said really big high school, so yeah, it's going to be a big school. Let's assume that. And then I'm going to do the same thing for seniors. 45 times 10 is going to be 450. I'm just adding that 0 at the end. So assume, I'm going to be lazy here, assume more than 450 seniors at this school. Okay, that's fine. And if we can do that, then we're going to go ahead and assume independence. So, yay, we can check the 10% rule. I know yesterday we couldn't because the questions had random assignment. So you just said, hey, if it's randomly assigned, there was no sample. But in this problem, there was a sample. So we checked the 10% rule. All right, here's what's new. We're going to do the large counts condition. New. So new. Okay, so this is what we're going to do. We're going to use p hat sub c, or PC, to check the large counts condition. What am I talking about? I don't know. Let's go to the formula sheet. Okay, so distributions for proportion right here. Okay, we're in the right spot. I don't know what these old highlights are from. Okay, look right here. Here is your p hat sub c. What does this stand for? Well, it stands for both of the proportions combined, and that's actually this formula right here. Let's make some sense of that. Okay, so let's find p hat c. Okay, this is how you do it. Go back to your problem. Okay, we have 28. Oh, yeah, 28 out of 50. So what is what I do? I do 28 out of 50. And then over here, the 29 out of 45, I'm just going to do 29 out of 45. So you add the two sample sizes together at the bottom, and then you add the number of people who said yes together at the top, because we're just combining it. And so everything that we learned yesterday was a lie. Well, not really. Your calculator basically combines this for you. It's called pooling, but I am showing you in case they're asking you guys to go more in depth on the free response on the AP exam. But who knows yet? So let's just let's go ahead and add these together. Oh, I need my calculator. Ooh. Okay. 28 plus 29 divided by, I'm going to put parentheses just in case here, 3/5. I want that in a decimal. Ooh, 0.6. Wow, that is so nice. So that means my p hat combined equals 0.6. So we're going to use that for all of our large counts calculations now. Okay, let's do the juniors first. So there were 50 juniors. And 1 minus 0.6. Oh, that's just 0.4. Okay, so that's for the juniors. We can see what this equals. And then we're going to do it for the seniors. There were 45 seniors. So I actually like this p hat combined because it speeds up my calculations a little bit. Okay, let's do it. 30. So that means this must be 20, because remember, if you add them together, they should add up to your sample size. 45 times 0.6 is 27. If you add them up, they must equal 45. Okay, 18. You can try it if you don't believe me. Well, my friends, these are all greater than or equal to 10, so we pass all conditions. So we can do the do part now, which I'm gonna, so this was plan, do. Okay, time to be amazed or just really annoyed at me because I never showed this to you before, how you could do it on your calculator. We're gonna do it the shortcut way up here. So remember, we're doing a significance test. The reason why I give you the notes for the confidence interval is because one of the homework problem is confidence interval review. Okay, let's do this. So now things get really weird because I want to show you my calculator. Okay. All right, so just quick reminder, I wrote on this post-it note over here, seniors, 29 out of 45 said they were going to prom at this school, and for juniors, 28 out of 50. Okay, so really sorry for being shaky. So let's use, oops, gotta hide my stuff. I typed it in earlier. Well, okay. Anyways, so you hit stat, go over to test, and you're gonna scroll down, look for 2 proportion z test, and look, that's number 6. So if you keep going down here to prop z int, that's for confidence intervals later. So sorry I never showed this to you before. 1 proportion z test is right here, number 5 for just 1 proportion. This is so wonderful. Okay, so let's do 2 proportion z tests. So I said seniors was my P1, so I put 29 right there. You see where the cursor is blinking? 29 out of 45. Sorry, it's not focusing. Okay, and then juniors is 28 out of 50, so that's where the next 2 come from. And then, I can't remember my hypothesis. Look at the direction. Oh, here we go. I said P1 is greater than P2. So, Then, oh, I already have it there. So you have three options. You have not equal to, less than, and greater than. I did greater than, so that's cool. And then you just do calculate. If you're curious what draw is, draws the curve for, this is not what I wanted. Oh, there it is. See, it draws the curve and it shades for you. Sorry, I have this weird line here from algebra. Okay, so you don't have to draw this curve on the test, but that's how you do it. And if you did, I love using the calculator shortcuts because if you remember two-tailed tests, when you have that equal to, the not equal to, if you were to draw this, it shades both tails for you. So the calculator actually calculates a two-tailed test automatically. You don't have to multiply your p-value by 2. Gotta match your hypotheses. Okay, all right, now let's do it. So these are the two things I need you to write down. The z, that's the z-score or the test statistic, and the p-value. So I know it just says p, but when you write your work, you're gonna write p-value. So remember these numbers, because I'm about to go back to my notability and we're gonna write them down. Okay, we need two things. Remember, we need the z and the p-value. So, all right, did you write down what the z was? Because I didn't. Just kidding. I think this was it. So, fun fact, depending on how you set up your hypotheses, you might get negative 0.839, and that's okay. So if you did this problem differently, it's fine with me, because it doesn't matter whether your z is positive or negative in this case, you're still going to get the same p-value. And then our p-value was 0.201. I'm going to round. That's it. This is all you need for do. Well, let's conclude over here. So this p-value though, that's really high. Remember, if the p-value is low, reject the null or the hub. If the p-value is high, you fail to reject. So this is so high, we're going to fail to reject the null. Let's write our conclusion. Since p-value of 0.201 is greater than the alpha level of 0.05. So I don't think they said significance. Oh, they did. Sorry, I missed that. It said use the 5% significance level. I was going to say if they don't say it, you can assume 5%, but they asked us to assume 5%. So because the p-value is higher than 5%, again, we fail to reject. P-value, we fail to reject the null. Okay. Okay, so if you fail to reject the null, so that means I wasn't able to reject it. That means I actually don't have evidence for the ha. Okay, we do not have convincing evidence for the, okay, I need to write the ha in context, and I highlighted that earlier up here, this thing. It's usually, oh, not that one. That thing, so I'm just going to copy that exactly. We do not have convincing evidence that a higher proportion of seniors there. I literally plagiarized that problem, that context right there. Does this make sense? Let's talk about that. So if it says we fail to reject this ho over here, the ho states that the proportion is equal, because look at that equal sign. So like the same proportion of seniors go as juniors. Since I couldn't reject that, that means I don't have enough evidence for the ha, which means that the seniors are going in a greater proportion than juniors. So this makes sense because I said since the p-value blah, 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 we fail to reject the ho. We do not have convincing evidence that a higher proportion of seniors are going to come than juniors. Okay, good luck. This check for understanding question here, I'm going to put on the Google form. So I made a different box for each part of the 4-step process for you to type your answers. If you prefer to write your answer, that's fine. Just send it to me via picture, and then this is your homework after the check for understanding. And notice that it is a throwback question on confidence intervals, so just make sure that you use the calculator shortcut to answer these questions. I want to see how you do. Okay, bye!